Okay. I will turn off my camera in order to avoid the lagging. Okay. So tonight we will cover the first part of text classification. Um, I believe you have studied this one in advanced data mining or advanced data mining. So the reason why we studied this one because it comes from the ancient problem for the librarian, in which when they store the document, they need to retrieve again. So the problem of a retrieval is that you need to know what name that you should call the document. How do you index the document? How do you organize? How do you store the document? Okay. So with larger collection, you need to label the document itself. Okay. Assign a unique identifier to each document. So, but the problem with that, you cannot allow funding document on a subject or topic matter, meaning that you only can index the document using the title of the book or the document, but to label them as a concept or a topic, for example, you want to label a group of books or a group of documents under computer science, they do not have the mechanism. Okay, so how would you cluster the document under a specific cluster or specific categories? So based on that problem, they have studied a way on how to cluster or categorize the document. Okay, to allow searching document on a subject topic, we must group document by common topics. So we should be able to cluster them based on common topic. Okay, and then we give name that will represent the whole document that is cluster or that are categorized under the topic. So each label group is called a class. Okay, so sometimes they call it one class or one cluster. So depending on the problem that we are looking here. Okay, so for text classification, basically what you need to do is you need to associate the document with the class. So how do you associate the document with classes? You have to know the content of the document. Then you can assign them to relevant class. Okay, so they call it text categorization, in which the classes are referred to as categories. But when we say categorization or classification, they are referring to the same process. And this is what we call the supervised learning or supervised task. They call it supervised task because you need to refer to the class in order for you to class them. You need to be able to assign predefined classes or predefined group. Then that's why they call it supervised learning or supervised task because you have something to refer to. Okay. So, but in most cases, you may not have the label. Okay. So you group them or you cluster them based on the content only. So this is what we call uh, cluster or clustering, and this is called unsupervised learning or unsupervised task because we do not have any label to refer to, but we know that by having document in the same cluster, meaning that they contain the same uh, content. Okay, so the content of the document are more similar in one cluster, but we do not have label. But we can come up with the label of the cluster by looking at what are the general concept or the general idea that we can come up from the cluster. Okay. So for text classification, it means we need to organize the information. So let's suppose we have a large engineering company with thousands of documents produced. So what we want to do is later on when we want to retrieve for reference for similar project, we can easily um, get the concept or get the keyword, then we can retrieve. Okay? So to organize large document collection, we need to be able to perform the text classification because only by doing that we can um, organize, store our document properly, and we always can add more document. Okay, so now they call it text classification because this is one of the area that need to be explored. Okay, but although this one has been pretty matured, meaning that a lot of research has been done, but they are still looking for new method that can produce this one um, that, that can perform the task easily or scalable, ready to cover large amount of document in for the multimodal. Multimodal means it contain images, audio, or video. So not only text, but we also looking at the content such as images. What else? Sometimes the document contain video or audio and so on. Okay. So in trying to perform the text classification, we use machine learning. This is the algorithm that learn patterns in data. So basically, we have three type of machine learning. So like I mentioned just now, we have supervised learning, unsupervised learning, and the third one is semi-supervised learning. So for the supervised learning, we need to have the training data because by using the training data, we are training the model. We say, okay, we have a list of classes and these are the document belong to those particular classes. We want them to learn what are the pattern that can be extracted to be considered as certain specific type of classes. Okay, so this is what we call the training data. Okay, so we have the content and also the label of the document. So the classes for input document. Okay, when we compare with the unsupervised learning, we do not have any label. So for that reason, we do not need to train the model. So what we do, we just measure the similarity between the document, how similar they are or how dissimilar they are. So example of method that can be used like neural network model, independent component analysis, and clustering. So in this lecture, we will cover clustering. Okay. We also have this semi-supervised learning in which we have a mix of data. A small number of document has label combined with larger amount of unlabeled data. Okay. So in this example, we are looking at they try to assign the label based on the small training data that they have. Okay? So sometimes this happen when you do not have enough data. You have a small portion of data or document that has label, but most of them do not have label. So this is what we call semi-supervised learning. Yeah. So how do we define the text classification problem? Okay, in the text classification problem, we can define or um, derive the classifier as you need to have a collection of document, which is the D. And of course, you need to have predefined classes C. So it will cover C1, C2 up to CL, where L refer to number of different classes. Okay. So by having a collection of documents and also these predefined classes, you need to find a function mapping that can map the document into the classes that you have. So um, if the document belong to that particular class, they will assign one. Otherwise, that particular document is not member of the class that we have. So we need to find this F. So when we say we need to find the F or the mapping function, meaning that we need to train the model so that it can effectively map the document to the right class. Okay? So this is the definition of classifier. You need to have a collection of document D, you have a predefined classes, and you need to train your model by having this mapping function. Okay. Okay. For high accuracy, we use supervised algorithm because we have the label to refer to. Okay. But in trying to perform the supervised learning, we have um, two or three approach. The first one is multi-model, in which one or more label are assigned to each document, or single label. That means each document will have at most single class. Okay, so for example, like this, when we say binary classification, that means we only have two classes, binary. Okay, so binary here referring to only two classes. If you have more than two, so this is what we call the multi-class. So which means that in these two supervised learning, one document only can be mapped to one class. So that is a single label. Okay. Okay. We also have this multi-label in which this photo can be labeled as cat and dog. No, cat and bird, in which both cat and bird exist in that particular photo. So it could be dog, no, it can be cat or bird. Okay, so that is what we call multi-label classification. Okay, okay. So having to know that for classification we need the document, we need the predefined classes, and also we need the mapping function. Okay, so for the binary function of document pair, okay, so for each of the document that we have, we can map them to a particular class. But for the binary, we only have two types of classes. So when we have multi-class classification, so that means we are looking at more than two classes at one time. Okay, so um, so for example, this is the classical set theory that belong to not tall or tall. Okay. But when we say, okay, what if we use the um, membership degree? So membership degree meaning that if they are here or above here, that means they are, the membership degree is more into tall categories. But if they are here, so they are more into the not tall category. Okay, so it depends on the degree of membership. So over here, this is gray area. So up to us how to define that. So there is three options here: tall, not tall, or somehow tall, or somehow not tall. Okay, so three categories here. So this is what we call the fuzzy set theory, in which they use the membership degree to say that okay, they could belong to tall or not tall. But when we compare to the classical set theory, the answer is two only, tall or not tall. So binary classification. Okay. So from the classical set theory, we can also expand to fuzzy set theory. So fuzzy set theory use the membership degree. Okay. Okay. Now we go into the unsupervised. So the unsupervised algorithm have clustering, naive text classification. So we will study these two. And for the clustering also, we have two types. Okay, we have studied this one in the advanced data mining, and we will cover another type of clustering, agglomerative. Okay, so that is the k-means, and this one they call it which method you use to measure the distance between two clusters, single link or complete link or average link. Okay, and also we have this text text classification by direct matching. So basically, this one use the distance method. Okay, so this one uh, quite straightforward. Okay, so they call it vector model because um, the differences between the document will be measured using the cosine function. So this is similar to the distance between the query and also the document one. So you have studied this one. So now we will say, okay, what is the distance between document one and document two? Okay, so we will study that one. Okay, let's go back to the clustering. No, this one just to give you an overview of the supervised text classification algorithm. So we have a lot of algorithm or methods that can be used to perform supervised learning. We have decision tree, nearest neighbor, relevant feedback, live bias, support vector machine, ensemble, and so on. Okay, so these are the subcategories again. Okay, you have studied this one, the Rockio. Okay, you also have studied this one in data mining, and also this one. Yeah, the live bias. Okay, and also I think boosting, the other boost. Okay. Okay. Now we start with the unsupervised learning. This is the clustering. You have the background, good background from the advanced data mining. So in which we will go over these two. Okay. Okay. So for the clustering, basically we will group them based on the content of the document. So we do not have the class label. So what we do, we cluster them based on the content of the document. Okay. So um, so what happened is that, for example, if we have this input collection and we say, okay, for the clustering, the only thing that we need to provide is the number of cluster that we have. So depending on the content of the document, we will group them into 5 clusters. Okay, so based on the content of the document, then we can extract the label or the concept or the topic. Okay, so here is the name of your new cluster. Okay, so how do you get this keyword? Is just by looking at what are the frequent term that exist in all of the document that you have. Okay, so if you compare with the supervised learning, basically you need to have the label. But for the unsupervised learning, you don't need the label, but you can produce the label later on. So for example, like this, we say k equal to 5, then we group them into 5 clusters, and from each of the cluster, what we do, we look at what are the frequent terms that used in this cluster, and we use that one as the label of your cluster. Okay. Okay. So the class label that we generate based on the cluster are usually of much lower quality because we just simply generate the label based on the frequent term that we have in the document. Okay. So so what we want to do is, if the class label are provided, cluster is more effective because we can measure the quality of the cluster, how pure is the content of the cluster. Okay, so we can use the entropy value. Okay, so now let's revise some of the things that you have studied in data advanced data mining. This is the k-means clustering. So what happens is that we need to have the number k, the value of k. Okay, so each cluster will be represented by its document centroid. So given the k, we will randomly pick the center, and then for the rest of the member of the document, we will assign them to the nearest centroid. Okay, um, so for the key means algorithm, we partition document among the k cluster. Each document assigned to cluster which is the closest centroid. So we randomly pick the center. The rest of the document will be assigned to the nearest center. So we use the Euclidean distance in order to measure the distance. Okay. So this is the formula. So this is the differences between 2 points in your space or solution space. So this is the vector. So K here referring to the number of element in your vector. Okay. So after you assign them to the nearest centroid, then you need to recompute what is the new centroid, because once you have gathered all the document, then maybe the center will be changed. So you will stop until there are no changes. For example, like this. So you have seen this before. So this one is k equal to 3. So we randomly pick the centroid, and then we assign to the nearest, no, we assign all the remaining document to the nearest centroid. Okay, once we assign them all of them, then we find the new center. So the new center will be moving depending on what is the average value for all the membership that we have. So it will move lah. Okay, so we will only stop when there are no changes of membership. Okay, so from iteration 1 become iteration 6. So we have a perfect cluster here because initially we have a good seeding. A good seeding means you pick randomly the centroid. So this is what we call the seed of the cluster. So sometimes you will get bad cluster. So the only way how you can measure is that you can measure the structure or the content of the cluster. Okay. So how do we apply this one in text? So given this all the document that we have, so if we were asked to perform the two means clustering, so we will pick randomly what is the centroid of the cluster. Okay, so we pick two lah from here. So this is the centroid or the center are picked randomly. So what happened is that for document 1 up to document 7, we will assign them to the nearest centroid. So we can use the Euclidean distance in order to measure the distance. Okay, for this one, these are the distance. So Notice that we are using the Euclidean distance in order to measure the distance between document 1 and document 3. And we also have to compare with between document 1 and 6. So whichever give you the smallest value, which means um, shorter distance, so we will assign that particular document to the center that give you the smallest value. So in this case, document 1 is closer to document 3. So for that reason, document 1 will be assigned together with document 3. Okay. So we will repeat this one for document 2, document 3. Okay, this is for document 2. So document 2 also nearer to document 3. So it will be assigned to the same cluster. Okay. Notice that I skip from document 2 to document 4. By right, I need to compute document 3. But since document 3 is the center, and you need to compute the distance between document 3 to the center, so basically itself is already computed lah inside the cluster. So we skip to document 4, then document 4 will give you um, nearer to the second centroid, and document 5 nearer to the first centroid, and document 7 nearer to the first centroid. So basically you have this cluster. Okay. So to move on, you need to find the new cluster. So now you have two cluster, right? Cluster K1 and also cluster K2. So to find the center is basically you find the average of all the vector value that you have for all those documents. So for example, for this one, so for the new center for K1, basically you add up all the value for T1, T2, T3, T4 and divide them by the number of documents. So for example, like this, basically you add up all this and divide by 5 because we have 5 documents. Okay, so similar to the second center. So basically we are looking at the average between two documents only because we have only two. So these are the new center that you have. So you will repeat again. You will repeat again. Okay. So having to know that we have this new center K1 and K2, then we will repeat again document 1, 2, 3, 4, 5, 6, 7, then assign them to the nearest center. Okay. So you will repeat this process until there are no changes of membership of cluster. No, no, no. There is no change of yeah, the membership are still the same. So you will stop. Okay. Any question? Everything okay?
Kira to okay.
Okay. Okay. So we will continue. So we will continue. Okay. So the idea with the bisecting k-means clustering is similar to what we have before, but this one bisecting means we divide the cluster into two. So no, it depends on the k. Okay, so means you will divide them into k. So for example, you have k equal to 2, so that means you will divide them into two. Okay, for example, like this, you bisecting using k equal to 2, and the stopping criteria is once you have the number of document is 4 or less, then you stop. So for example, like this, we have 15, k equal to 2 means we divide them into 2. So how do we divide them into 2? We just pick randomly what is Contohnya macam, let me, we find two cluster here. So basically, we repeat what we have done in the first example just now. We find two cluster within this 15 document. So we have two. So again, once we have this cluster, then we find again two cluster within this component. Okay? Since the number of document is 4, then we stop over here also. We stop except this one. So over here we are using the bisecting k-means clustering. So in this one we have finally 5 cluster. Okay, 5 cluster with the stopping condition 4 means at least no, at most 4 document in one cluster. Okay, so this is what we call bisecting k-means. K equal to 2. So this one we reapply what we have studied in the previous slide, but we only set k equal to 2. So they call it bisecting, k means clustering. Okay, so now we move on to the next one. This is a bit difficult because the problem with the previous one is that we are not sure what is the value of k. What is the best value of k? Okay, so by having the agglomerative, uh, referring back to the k-means is that remember when you were asked to find the cluster, you pick randomly, right? You pick the center randomly, right? So you never know what is the best seeding, what is the best position for the centroid. Okay, so the best thing about this agglomerative hierarchical clustering is that you will not need to find the center. Okay, you don't need to find what is the best center because basically they will give you everything automatically because the way they form the cluster is they're merging the document into cluster. So depending on similarity, okay. So the goal is okay. This is what we call decomposing. So this is similar to the bisecting, but we also have this agglomerating in which we start from this cluster and we merge them to become one. But there are more process here. Okay, so let me show you what happened here. So because when we want to merge the document, we need to know the distance between each of the document that you have to all of the document that you have. So for that reason, you need to have this n times n similarity matrix, where n is the number of document that you have that need to be clustered. So for example, um, so so based on the distance here, you find the two closest cluster and then you merge them. Okay. So once you merge them, then you need to recompute the distance between the new cluster to the rest of the old cluster. Okay, so for example, if we have this, okay, this is how you use the single link, complete link, and average link in order to determine the distance between two clusters. I will come back this one later on. Um, let me give you the idea first. Okay, in this example, how many points or how many documents we have? We have 3, 3, 4, 12 documents. So we need to have 12 times 12 matrix because that one will tell you what is the distance between point 1 to point. So we need to find this one. Okay. So that's why we have to have the 12 point times the 12 point here. So for this one, of course, we don't need to compute this one. Okay. So once we get the distance, so we need to find the smallest distance here. Then we need to merge. So for example, if we merge this one and this one, um, because the value here is smaller, then that means we need to reduce the matrix from 12 times 12 to become 11 times 11. Okay. So let's suppose we have this one already. So we have 5 clusters. So that means we have 5 times 5 matrix. Okay. So let's suppose we join these two, C4 and C5. So that means this one. So that means these two has been merged. So you need to find what is the new distance between the newly merged cluster to the rest of this is the old cluster that we have. So we need to find this. Okay. So the issue here is that because we have the single, complete, and average link, so that refer to what is the distance between these two clusters. Okay. Because you want to know which cluster to be merged. Okay. So there are a few methods. Okay. So the first thing is called single link or the minimum. Okay, so that one will give you the distance between two clusters that has minimum distance between two different document belong to two different cluster. Okay, single link. If you take the furthest one, this is what we call the complete link. Maximum distance between two items belong to different cluster. And then we also have the average link, which take the average of the distance between all the member from one cluster to the other cluster. Or you can take the centroid. How do you get the centroid? You just take the average of all the membership that you get from this cluster. Okay. So when we talk about agglomerative clustering, we have to know which approach are we using. Are we using single link or are we using complete link or are we using average link? This one will have high computation. So in most cases, by default, we use this one, distance between centroid. Okay, so the centroid can be computed by taking the average of all the vector value for each of the item that we have in the cluster. Okay, okay. Let's take a look at how we can apply this hierarchical clustering for the document. Okay, so let's suppose we have this document 1 to 4. So what we need to have is 4 times 4 matrix distance. So we have all this, we need to compute lah. So that is your metric distance. Okay. So we use the Euclidean distance also in order to compute the distance. So the smallest value will be this. Okay. So we merge these two document 2 and 3. And for the new value, we take the average lah. So we take the average of this, this, and this, and this. So we get 1.5, 1.5, 5, and 2.5. Okay. So once we get that one, so we need to recompute the distance matrix again. So this is your distance matrix. Okay. So the smallest one is 3.28. So we will combine this. So document 2 and 3 will be merged with document 1. So we have that one. Okay. So now we have the new center there. Then lastly, we merge. So when we draw the sequence of this, um, basically the sequence is we have P1, P2, P3, and P4. So first we merge this one, and then we merge which one? We merge document 1, right? So we merging them. Okay. And lastly, we have this. Okay. So if you look at the pattern here, this is what we call the hierarchical clustering. You merge one cluster at one time. So initially, each document will be presented as individual cluster. So we have P1 up to P4. This is individual cluster. Okay. So once you merge these two, so over here, basically you have P2 and P3. So the center will be the average of these two. Okay. So you merge again this one. So the center here would be the average between all these three documents that you have. Okay. So now, for this one, they use the centroid. So now, how do we apply the single link or the complete link? Okay. So now, okay, let's suppose we use this single link. If I go back to here, okay. So the good thing about this one is that let me erase some here. Okay. The good thing about this is that we can always find the cluster here. Let's suppose we say, okay, I want to find two cluster. So you just have to cut across here. So this is two cluster, one cluster and second cluster. Okay. So if you want to have three cluster, then you will cut across here. So we have one, two, three cluster. Okay. So there is no issue of where is the best seeding. Where is the best seeding for your cluster? Because for this one, they just merge the closest two cluster together, and there is no issue of finding the best seeding. Okay. Okay. Now let's suppose we want to use single link, and we want to form two cluster here. So we will, since they are still individual item here, so we we measure the distance. We pick this one, and then we merge those two. Okay. So we have, okay, now once we merge those two, so we have new cluster, right? 2 and 3. Okay. So that means this one is belong to one cluster. So for us to compute the distance between this cluster and with this cluster, we need to find the minimum distance between these two clusters based on what is the minimum distance between the member of this cluster to document 1. So basically we are comparing the distance between this and this. In the previous example, we just simply take the centroid. But for a single link, we are referring to what is the nearest distance between two members belong to two different cluster. Okay. So for example, this is document 1 and 3 and so on. So notice that here, the document 1, you need to know what is the distance between document 2 and document 3. So Based on this, we take this one as the distance between the document 1 and document 2 and document 3. Okay. And also for document 4, since they are looking at this cluster, okay, so this is basically, so the distance will be this one because this one is the smallest. So this one is referring to the distance between the document 4 to the document 2 and 3. Okay, so we take that one. So that means between this, and this is the smallest one. So we will merge document 1 to 3. Okay. No, document 1 to 2 and 3. So basically, what you have here is first you have 2 and 3, and then 1 here. But notice that the way we decide what to merge depending on what distance you are using. This one we are using this one, and this one is we using this one. Okay, so we'll merge, and that's it. So this is for your exercise lah. Okay. Okay. Any question? Let me get a water first. So we 3 minutes lah. Let me get water. Okay, okay. Let's continue with the next one. Okay, do you have any question on the agglomerative hierarchical clustering? No question.
No question, Doctor.
Okay. So we will continue with the knife text classification. So this is they just call it knife text classification because we are using the distance between the document to assign the label. So basically, we are applying the technique that we used before in order to measure the distance between the query and also the document. Okay. So for the knife classification, they are defined to have a collection of D. So this is set of document, and also we have predefined classes. Okay. So the idea is we will match the document term to the class label. Okay. So what we need to do is when we know the distance between the document to the group of document, then we assign the label of that group of document to the new document that we have. So the partial matches are allowed because we are looking at the distance only. So it doesn't have to be matched. The content doesn't have to be matched with all the content that we have in the predefined classes that we have because we are using distance, right? So we are not using actual or the actual matching of the keyword. We are only using the distance to measure which classes they belong to. Okay. Okay. So what happened is that we have the collection of document to classify. We have the predefined classes, and each of the document we will present them as vector, and each of the classes also will be defined as vector. They use the label. Okay. So for each of the document that we have, we need to compare or find the distance between the document and also the classes that we have. So this is similar to finding the distance between document and also the query, right? But for this one, we are looking at the class. Okay. So we will assign this new document to the classes with the highest value of similarity. So that means we are looking at which document or which class that um, nearest to that particular new document that we have. Let me give you some example. Okay, given that we have four documents here, okay, and we say this is the label of the classes that we have. We have A, B, C. So in order for us to classify individual document that we have, basically we just compute the distance between this document one with the class A, which is this one. So this is similar with the query. Okay. So the label here is just the text of document that you have. So we will compute the distance between each class and the document where Q is the class member. Where is Q? Q is this one. Okay. So you still remember this one, right? So this one is basically we are looking at the distance between the document and the query. Okay. So basically we are using the same formula here in order to compute the distance between each document that we have to the label. So the label here consisting of few terms to describe the class. Yeah. So actually three lessons that you learned today. The first thing is the K means clustering, and the second one is the actually they call it HAC, hierarchical agglomerative clustering, HAC. And the third one is naive text classification. Okay. Mm, I think that's conclude tonight's lecture. What's the time now? Okay, 9:15. That's nice. Okay. Any question?